one day, but I figured I'll be nice. Yes, you can. So, review polynomials. This slide, I'm not even going to do it because we have foiled 100 times in this class already. So, remember, a binomial times a binomial is foiling. Do it on your own, see what you get for an answer. Okay, so your answer should be 6x squared plus 29xy minus 5y squared. Doesn't matter the order you put it in, technically speaking, but if I were you, I would get very used to putting it in that order. So x squared first, and then your next lowest x would go next, so that x is just exponent 1, and then your last thing has no x's. Get used to going descending order like that, but also alphabetical. So the highest one came first. We could have done it x squared or y squared, but then we do alphabetical, so x squared goes first. And then you work your way down from the x's. You need to be used to doing that because that's going to be a lot of this unit, is getting things in the proper order. Okay, expanding more than binomial times binomial. So here we have a trinomial times a trinomial. You have two ways you can do this. You can distribute in, meaning you're going to take this first thing and you're going to multiply it by the other first thing. And the first thing times the second thing, first thing times the third thing, and then do it again for the second thing. Or you can do a giant box method. I think a lot of you guys prefer that box method. Yeah? So I'm going to show you guys the box method. Hey, this is great. So, our box method, it's the same thing as foiling, except now we have a trinomial. So you're going to take this first one and set all three things up on the top of the box. So your first thing should be 3x squared. Your second one would be 10x. And your last one would be negative 9. Remember that trick of the negative 9? The negative stays with that 9. The next step is take your second trinomial and put it down the side of the box. So you have, I can sit down perfect, x squared, 2x, plus 1. And now you've made your grid. So you guys are pretty good at this. You have your grid, I'm doing it in red. And then you fill in each spot of the grid. So I'll do the first one, and then you try to fill in the rest of the grid. So the first one would be 3x squared times x squared. You add the exponents, so it's 3x to the power of 4. Try to fill the rest of the grid. So your x squared and your 10x would be 10x cubed. X squared times negative 9 would be negative 9x squared. 2x times 3x squared would be 6x cubed. And then you have 2x times 10x, that's 20x squared. Remember, you multiply variables with variables, coefficients with coefficients. 2x times negative 9 is negative 18x. And along the bottom, it's just the exact same thing, so 3x squared, 10x, negative 9. If you did that all correctly, that's kind of just half the battle. I think the hardest spot now is keeping everything in order when you do the box method. So bring all your like terms together. Start with your highest exponent and work your way down. So our highest exponent is this x to the power of 4. So that's the first I'm going to do. 3x to the power of 4. And then I'm going to check it off. I'm going to do a little blue check mark. Now do your x cubes. That's the next highest one. I have 10x cubed and 6x cubed. Add those together, that's 16x cubed. Now your x squareds. I have 3x squared plus 20x squared, so I'm at 23x squared, minus 9x squared. So I drop down to 14x squared. And check, check, check. Now your x's, so 10x minus 18x is minus 8x. Check, check. And the last one's minus 9. When you guys do box method, you were foiling, a lot of you use box method, and you were messing up that step just FOILing, bringing together your like terms. When you're doing trinomials, it's even harder to bring those things together. So make sure you are checking things off as you're bringing them together, and make sure you go slowly through it. Some of you guys are getting ahead of yourselves and kind of ripping through as fast as you can. Just take your time. You'll be good. Okay. Next one. We're going to start factoring. When we factor out our common factor, we place it outside of the brackets, and the answer to the division goes inside the brackets. That's just a fancy way of saying how we factor. Remember, factoring is you're taking something that could multiply into all these things, and you're dividing it out. Start with your coefficients. I have 15, 5, and 25. What's the largest number that could divide into all of those, Zucker? 5. So I'm going to divide all of them by 5. So I've got 3 plus 1 minus 5. I didn't even worry about the W's yet. The 5 that I divided out, it goes way out front in front of the brackets. Do the number first. Now let's worry about the W's. Yeah. That's what we're going to do right now. Yeah. Now we're going to worry about the W's. You could take out a W squared out of all of these. Whatever the lowest exponent is how many you can take out. So if there's no W in one of them, then you couldn't take out a W. You have to be able to take it out of every single one. So there's a W in every single one. And now we're going to divide out whatever the lowest exponent is that we see. The lowest exponent we see is W squared. So we're going to take out a W squared. That makes it 5W squared out front. And now we're going to take that W squared out of each term. So W to the power of 4 divided by W squared, you just subtract the exponents. So you have a W squared here. W squared divided by W squared, what do I have? Nothing. So I'm not going to put anything in that blank. And the last one, W cubed divided by W cubed. Just one W left. What we just did was we took out the greatest common factor. That's going to be your first step in basically every question for the rest of the unit. When we're doing these things, basically anytime you can, we call it GCF, greatest common factor, you do it. Simplifying makes things easier. Try taking the GCF out of these two questions. Try it on your own. Okay. If you look at the top one, what I factored out was a 6x squared. So I found that 6 was the largest number that divided into all those coefficients. And x squared came out because that was the lowest exponent that I saw here. I divided that out of each one. So 18 divided by 6 is 3. 24 divided by 6 is 4. 54 divided by 6 is 9. And then just did my subtraction on the exponents when I divided them out. The next one. And there's two things that most people probably did. What's happening up there? That's so exciting. But focus on this for 2 seconds. I'll finish this one. Okay. I took a 4 out of all these. And some people took a 6 out of all these. Which isn't wrong. It's not wrong. But the largest number you could have taken out was 12. So if you look at my answer right now, I can take 3 more out of all these. That's how you know you didn't get the largest one. Because there was still more you could have taken out. Okay. So I divided a 4 out, which is like kind of a common thing that people would do wrong. All you would do to fix this mistake, so you don't have to redo your entire thing, just look back at your answer and make sure there's nothing extra you can take out. In this one, there is. So when I take out 3 more, you just do 4 times 3 in the front, and that's where your 12 comes from. Okay? That's going to be a common thing that we do wrong, and it's not doing anything wrong, it's just you missed the greatest common factor.
You also, like, because you can take out another x.
That's a great question. So also check your variables. And make sure that you know that because there's no x here, that's like an x to the power of 0. So you can't take any more out. You have to have an x in all of these to be able to take anything out. Okay, binomials. We're going to talk about difference of squares, which you guys should be pretty good at also, because it's kind of what we were doing last unit. It's a little bit of a twist. So a difference of squares happens when you have a perfect square, so like 4, 9, 16, any of those perfect squares, and you minus another perfect square. So if you had 9 minus 25, we call that a difference of squares. Remember, difference means subtraction. Squares is talking about perfect square numbers. Question?
You'd be like, if there was like an x squared, that'd be a perfect square.
Yeah, x squared would be a perfect square. X to the power of 4 would be a perfect square. X to the power of 6 would be a perfect square. Any even power of x would count as a perfect square. I'll let this one go. I've distracted their class.
But it's so easy.
It's so easy.
It would be wrong not to.
Okay. This one. Anytime you see two things and they're subtracted, you now need to be able to identify if they're perfect squares or not. If you look at this, 4, perfect square. X squared, perfect square. And 9, perfect square. You have all perfect squares and they're subtracted. The hardest part is, you guys can usually do these, the hardest part is identifying that you need to do these. So always check when you have two terms to see if they're perfect squares. When you do have perfect squares, what you do is you square root all of them. So what's the square root of 4? 2. What's the square root of x squared? And what's the square root of 9? That gives you your first binomial. Your second binomial is the same thing, 2x, 3, but it's plus. Doesn't that look an awful lot like a conjugate? That's basically what we've already been doing. Why can't you do it with addition? Great question. If this is addition, it's not a difference of squares, it would be an addition of squares. So if you did your FOIL, like if you did this, you wouldn't be able to get an addition by itself. The big key is when you do -3 times +3, it'll always give you a negative number, which means it always has to return to a minus at the end. That's why it can't be addition. And that's a trick that we're probably going to throw at you. So there are difference of squares that are actually added, which means you can't do them. Okay, look at this next one. If you want to make your life easy, you always want to take out your greatest common factor right off the bat. What's our greatest common factor for this question? 8. See how I can take an 8 out of the 16 and an 8 out of the 64? That's what we want to do. Your first step is still always greatest common factor. Yeah, take 16 out. Good catch. Sorry. Take 16 out of each of these. So you're left with 16 bracket x to the power of 4 minus 4y squared. Pardon? Okay. And now you have a difference of squares, but before you actually didn't. Well, you did, but you would have had to do it twice. You had a double difference of squares. So you could have done difference of squares, but then you would have had to do difference of squares again, and it would have sucked. So if you take out your GCF right off the bat, it'll make your life easier in the long run. This, difference of squares. So what do you do to get your answer for a difference of squares if you have to factor a difference of squares? Square root the first term, so it becomes x squared, minus square root the next term, which is now 2y, And your next binomial is the exact same thing, just with an addition.
Why do you do this?
Why do we do it? It's a great question.
I guess just
What's a real life application?
a longer way
Um,
to break it.
Who are real life applications?
So then why do we do that?
That's a good question.
To know.
My lecture on why math matters.
Like usually there's
Do you wanna go
problems
through this?
to solve.
So why math matters.
You should have
Okay.
recorded that, honestly.
Yeah, I think I recorded that last week.
Inspiration.
The next thing you want to do is make sure you didn't miss anything. Emily, go. Get her bowl water, please. Is there any more greatest common factors we can take out? No. The next thing you want to ask yourself, when you have binomials, is there another difference of squares that you need to take out? No, there's not. Had you done the question the other way, there would have been. There would have been another difference of squares. So always check for those things. Okay, this one. Doesn't look like a difference of squares, but it is a difference of squares. What is 1 squared? 1. The dreaded 1. 1 is a perfect square. So up here, because 1 squared is 1. And if you square rooted 1, still 1. So up here, you have a perfect square. Is the denominator a perfect square? 9 is an obvious one. Okay. This is a difference of squares. So let's do what we do. Square root the first term. What do you get? You get 1 on the top. What's on the bottom? 3. X squared. What's the square root of it? Okay. We minus. What's the square root of 64?
8.
Perfect. There's your first term. Second term. What's it going to be?
Same
Same thing, different sign. Perfect. We're factoring. This is called factoring a binomial. So if you get a question that says factor and it's a binomial, you're probably doing this. Number 4. Do you see that it's a difference of squares? Okay, try it on your own. Try number 4 on your own and then check your answer.
Did not put anything in front.
No. Nothing goes in front.
How come it did not?
That's a greatest common factor. That's a great. The question, 2 questions came up. Can you do it again? You can't do it again. X squared is a perfect square, but the 3 isn't, and the 7 isn't. You have to be able to the square root everything. It can't just be one part of the question. Second question that came up was if we're factoring, why don't we have a number in front of the brackets? Like we do when we do greatest common factors. That's usually what we do, right? And the reason is you can imagine this second binomial, that one, this one.
Whoa.
That second binomial, that's your number in front. If you were to FOIL this out and multiply that into the brackets, you would get our exact question back. You'd get the exact same thing. London.
So, if there was perfect squares like just on the bottom, it's just a square root as long as there are square roots on the bottom.
So if there was like a square root, say on the top, say this was a 4 and over 7?
No, like a 4 over 9.
Yeah.
3 over 9, as long as there are square root signs on the bottom, you just make square root.
Right. As long as you can get perfect squares, you can keep going. So if it was 4 over 9, you could square root that 4, square root that 9, and do another difference of squares. Ty.
If I'm looking at a question that's like are important to factor this difference of squares, I can just look at both like the 3 over 7x and like the minus 5, 9, and like times basically square root them, like reverse it kind of.
Yeah.
But not worry about like the inside term, just those cancel out.
Exactly. The outside and inside term cancel. Yeah. That's exactly what you can do. And a lot of you guys have picked up on that last unit when we were doing conjugates. This is a conjugate. expression conjugate. Outside and inside terms cancel, and they mash in. All you're doing is squaring and squaring. Yeah. And some of you were picking up on that, and we're doing it really fast on your test. And that was nice to see. Okay, slide 9. This. Is this a difference of squares? Right, so right now it's not a difference of squares. But the first thing you always do is take out a greatest common factor. You can take out an x from both of these. So take your x out of both of these, and you are left with w squared y squared minus x squared z squared. Now you have a difference of squares. So remember, step 1, GCF, greatest common factor. Step 2, try to factor it. Tie. Okay. So if we try to do this, we have x still way up front. We have w times y minus x times z. In the other bracket, we have the exact same thing, but with a plus. Just like that. So I've square rooted that w goes crazy. I've just square rooted everything. That's all difference of squares is. The next one. Is the next one a difference of squares?
Yep.
It is. And you do not need to take out a greatest common factor, because there isn't one. So, square root the first thing, and you'll get x over 8 minus y over 7. That's in brackets, and you multiply it by the exact same thing, just now it's an addition. You assume you're getting the hang of this? Mike. Good question. If you have a binomial that's not a difference of squares, and there's no greatest common factor, it's not factorable. So you just would leave it alone. And that might pop up. So that's a good question. Okay, trinomials. Remember our lovely diamond method. We're going to bring that back. Okay, well, I'm going to explain it maybe in a different way. Or maybe the second time that you've seen it will be better for you. Because that also tends to happen.
Can you give us figures for rivalries?
So, anytime you have a trinomial, that's degree 2, meaning that the highest exponent you have is an x squared, a y squared, a sine squared, a cos squared. That's where we're headed with this class. Anytime your highest exponent is 2 and you have 3 terms, you're going to do what we call diamond method. So, I'm going to go nice and slow in case you haven't seen diamond method before, and in case it's completely foreign to you. A trinomial, if you look at this, that's not a coincidence that we label these A, B, C. That's not a coincidence. Those letters are on purpose. So if we look back at this, label in your letters. A is the first one, B is the second one, C is the third one. But it has to be in that order where it's x squared, then x, then no x's. So remember when you asked, somebody asked previously, does it matter the order we put it in? Now it matters. A is the number in front of the x squared. B is the number in front of the x, and C is the number in front of the no x's. Diamond method. Okay, I'm glad that some of you guys are getting the answer, but some of us need help, so you guys need to keep quiet, please, so that others can pay attention. Diamond method sounds exactly what you think it is. It's you create a diamond. Oh, it's not bad. On the top of the diamond, you have A times C. On the bottom of the diamond is your B value. So in black, I'm going to do our question. Make your diamond. The top of the diamond is A times C. My A value in this question is 1. My C value in this question is 15. 1 times 15, the top number of my diamond is 15. B goes on the bottom of the diamond. My B value is 8. Is everybody happy with how I've created my diamond?
Wait, what is it?
Kind of foreign. So, quick review. I've got a trinomial. It's x squared, then it's x, and then it's no x's. So what we do is we label our numbers here. There's an invisible 1 in front of this, right? That's your A value. Your second value in front of the x is your B value, and your last value is your C value. In our diamond, the top is A times C, the bottom is just B. Perfect. Now we need to find two numbers that are going to multiply to be 15 and add to be 8. So that's what you're looking for. So I'm going to write that up here. So you want two numbers that multiply to be the top number, add to be the bottom number.
Doesn't matter which side.
And it doesn't matter which side you put them on. So we've got 5 times 3 gives you 15, and 5 plus 3 adds to be 8. Those two numbers, 5 and 3, become the size of your diamond. 5 and 3. It takes some practice to be able to get good at that. You now can change this trinomial into two binomials using the sides of our diamonds. So the sides of our diamonds become our numbers that we put into our two binomials. So that would be our final answer. And I'm going to review one more time how I got it, because I kind of skipped something that I probably shouldn't have skipped. When you're factoring a trinomial, your goal is to get two binomials times each other. Your goal is always to get two binomials times each other. It tells you the zeros of your graphs. It tells you where your graph is going to cross the x-axis. That's why we look for these zeros. So when you're factoring a trinomial, your goal is two binomials. We know that the first thing in your binomial, x and x, it has to be x and x, because that's the only way we can get this x squared. So we can start off already knowing our binomial is going to be x something times x something. Those somethings come from your diamond method. So if you do the diamond, that'll fill in your blank. Positive 5, positive 3. Okay, we're going to do one more together. Nice and slow. If you look at question B, am I good to erase question 1? People start writing notes. I'll wait for you. Okay. Question.
When is it you have to look at like the 5 and 3 and decide which side, like you have to go to the opposite side?
That's a good question. That's next. That's coming up. Yeah. Yeah. So it's not B, but or number 2, but it's number 3. So next slide, I'll start. Okay. Let's look back. What's our A value in this one? 1. So your A is right there. Your B is negative 1. Make sure you understand that's a negative 1. Your C value is a negative 12. Those negatives are going to be important. Our diamond method, and I erased it. A times C on the top, B on the bottom. So if we look at our particular question, A times C, we have 1 times negative 12. Negative 12 on the top. On the bottom is your B value. negative 1. You need numbers that multiply to be the top, add to be the bottom. 3 and negative 4 would multiply to be 12, negative 12. And 3 minus 4 would add to be negative 1. So those are my answers, 3 and negative 4. We know that our final answer is going to be 2 binomials, because that's the goal of this course right now, is to turn trinomials into 2 binomials. We know that the first one has to be an x, because if you were to FOIL this out, x times x is the only way you're going to get x squared. So we know the first terms have to be x's. The side of your diamond fills in the rest of the binomial. Plus 3 minus 4. Keely.
Isn't there, like, maybe it's like, isn't there where, like,
We have to divide?
yeah.
It's coming. Awesome.
Doesn't matter which was
Good question. Doesn't matter the order you put it in. If you had x minus 4 times x plus 3, that's the same answer. So you're good. John's the same question?
Yeah.
Okay. All right, those are basic. Yeah, those they like pumpkin spice lattes and Gilmore Girls. Those are basic. Get it? Nailed it. Okay. Those should be easy. If they're not easy, tonight needs to be a lot of practice, because I'm not going to be able to spend time doing this in the future. Trinomials that are in the same form, but a isn't equal to 1. Our last 2 examples, a was equal to 1. If a isn't equal to 1, we have to do something a little special. We have to divide out by a at the end. So I'm going to fast forward and just do an example. That's the best way to do it. We need a diamond, because we have 3 things. On the top is a times c. A is 2, c is 3. On the top is a times c, so it's 6. On the bottom is negative 7. You need 2 numbers that multiply to be 6 and add to be negative 7. That's a tricky one. Remember, anytime you have a positive on the top and a negative on the bottom, your 2 answers will be negative. So negative 6 times negative 1 would give you positive 6, would add to be negative 7. So that one's a little tricky. Negative 6, negative 1. We know ready? Okay. We know our answer is going to be 2 binomials. We know that we need an x at the front of each one. Because that's the only way that you're going to get x squared. Because the first terms create that x squared. But the problem here is we don't need x squared, we need 2x squared. So what I do is I put 2x squared in for both of those. So it becomes 2x, 2x, like that. Just wait, I'll show you. I do 2x and 2x because I know I need to get a 2 eventually. So that's why I put the 2 into both spots. Now the sides of my diamonds come in. So negative 6, negative 1. But Hunter's got a good point. We can't have 2x times 2x because that would actually be 4x squared. So what you need to do is we have an extra 2 in there. You need to divide one of these binomials by 2. Which binomial can be divided by 2? The one on the left can be divided by 2. So you divide it by 2. The 2x is divided by 2, and the 6 is divided by 2. And your final answer becomes x minus 3 times 2x minus 1. We'll do another one together. We're going to do a bunch of these ones together. These ones are hard. Hammer.
The second one isn't possible unless it's plus 4. I'm pretty sure because there has to be a lesson about that. Like when you do the giant method, that's not possible.
Yeah, we'll just do it. We'll do it the way it is. Jacob. Okay. I have a question here and I want to answer it. Why can't I just put x squared?
Like in the second binomial, instead of having 2x in both.
So if you wanted to just right off the bat make this x minus 1,
Yeah.
if you can see that, that's fine. Like if you can tell which one off the bat needs to be which, go ahead. If you can, if Dunny showed you, which I'm sure he did, that you're going to divide this 6 by 2, so you know that the negative 1 is going to be the one that doesn't have it, that has a 2, that's fine. If Dunny told you that and that makes sense to you and that's sticking, do that. I'm going to do my method, and if you don't have a method yet, maybe you can pick up on mine, and if it doesn't work out, I'll show you another method after. So if this all doesn't make sense, so we're going to do this, you're going to go home, you're going to practice, and it doesn't make sense, come to me, I'll show you another way of doing it that might make more sense to you.
I was just gonna say, so you just leave the other one.
Yeah, you just leave the other one as 2x minus 1, because I know I need one of my 2's to stay. Okay, number 2. We're going to create our diamond. On the top of our diamond is a times c. 15 times negative 4. And that's going to be negative 60. And I always keep the page dark a bit. Negative 60. On the bottom is my b value, which is negative 17. My b value, negative 17. I need 2 numbers that are going to multiply to be negative 60 and add to be negative 17.
3 and 20.
Yeah. So is there an easier way to figure it out? Okay, my suggestion, if you have a hard time with this, you can't see the numbers, because the numbers are, for this one, negative 20 and positive 3. If you're having a hard time seeing that, what I want you to do is just focus on the multiplication. The adding could be anything, right? I could tell, if I said I need to add 2 numbers to get to 1, I could go forever. 0 and 1, negative 1 and 2, negative 2 and 3, and just keep going forever. So the addition part is hard. Start with the multiplication part. And what I want you to do is write out all the factors of 60. So 60 and 1, 30 and 2, 20 and 3. And then keep on going down the list. So you're going to have 15 and 4, and then probably a bunch more. But the thing is, your things that can multiply to 60 are limited. So we can look at all these and see if there any way we could add these to get to my number. Could I make either one of those negative, 60 and 1, to get to negative 17? Never going to happen. Could 30 and 2 ever connect to be 17? No. Could 20 and 3 ever connect to be 17? Yes. So that's the best way, if you're having a hard time finding numbers, break down the factors of the multiplication. Because that's the only one that has limited numbers. The addition goes forever. Okay. We've made our beautiful thing happen. Our diamond is complete, but now we need to do our brackets. So we know we're going to have a binomial times a binomial. We know the first term has to be 15x squared. The only way to get an x squared is to have an x. So I'm going to make both of them 15x. I know that's too many, and we're going to deal with that later. Minus 20 goes in the front, plus 3 goes in the back. Order doesn't matter. But we're not done because this answer doesn't make sense because 15 is too many. We can't have 15s in both of these. So we need to divide one of these by 15. Neither one divides by 15. 20 can't divide by 15, and 3 can't divide by 15. So your next step is you need to be able to divide these two things by something that would multiply the 15. So before we were just doing divide this one by 15, divide the other one by 1, and leave it alone. But we could also divide the first one by 5, divide the next one by 3. Because 3 times 5 is 15, and that's how we're going to take our 15 back out. Could either of these divide by 5? The first one, 5. Could either of these divide by 3? The second one.
So you do division to both.
So now this one's a special case. I have to do division on both of them. Because I wasn't able to take 15 out of just one of them, I had to divvy it up among the two binomials. So the first one, I divided by 5. So it becomes, I'm going to write my answer over here in blue, 3x minus 4. And my next one is 5x plus 1. Quick review, why I did that. I put 15x in at the beginning for both my binomials. Because I knew at some point I had to get 15x squared. I did my diamond method. I subbed my numbers in after my diamond method. I then went back to the fact that I added 2 15s when I only needed 1 15. So I have to divide one of those 15s out. Neither one could be divided by 15, so I had to divide by two things that would be a product to be 15. Divided the first one by 5, the second one by 3, because 5 times 3 is 15. So I've divided my 15 out just in chunks. Alright, let's do another one. This one, try it on your own. Give it a shot on your own, see if you can't factor that thing. Question 1, you should have broken down into x plus 5 and x plus 2. Question 2, you should have broken down to x minus 5 times x plus 2. Question 3, if you made your diamond, you would have got negative 24, and you would have got negative 5 on the bottom. What multiplies to be 24 and adds to a minus 5? Negative 8 and positive 3. If you did your brackets, you knew you had 4. Oh, I didn't even realize. This one's an x to the power of 4. So, how do you get x to the power of 4 when you're multiplying two things, Liam? Yeah, instead of an x, it's 4x squared at the beginning of my brackets. Because I know the only way to get x to the power of 4 is x squared times x squared.
What about the x squared for the 5?
The x squared in the middle will now work itself out. So we don't need to worry about it. When we FOIL, your outside and your inside terms would create that x squared in the middle. Hi.
By doing that, just division on the output in like the diamond, if you divide by 2, divide by 4x, like define the 3 plus and minus going, find
Yeah. So when you divide here,
yeah, divide by one of those numbers.
you can divide 4 right here.
Yeah, and that does something.
So that makes that negative 2. And whichever one has the -2 can't have anything in front of the x. I'll show you after. We'll go through it after. For now, we're going to stick with my method. Okay. Back up here, guys. We got -8. I'm going to take my two sides of my diamond and I'm going to plug them in. -8 plus 3. I know that I added 4 twice, and that's too many times. So I need to try to divide 4 out. Can I divide 4 out of one of these binomials? The first one. So divide the first one out. And you'll get x squared minus 2 times 4x squared plus 3. Emily. Yeah, I'll look at it. We're going to go over 4 together, and it's going to be our last one. So if we're quiet, I'll get through it quick. And then we'll be done. Band-Aid. If you look at 4, remember the first thing you want to check is, do you have a trinomial? Yeah, we have a trinomial. Is the highest exponent going down? So it's highest exponent, the middle exponent, and the least exponent, and it is. So we're in the proper order. That's important. We haven't really been talking about that, but it is important to check that you have the proper order. What goes on the top of your diamond? A times C, 99 times 2, goes on the top of your diamond. 198 is on the top of your diamond. On the bottom, minus 31. Those are hard numbers to just know what would multiply into 198, what would add to negative 31. So making your chart right now, making your chart right now of things that would multiply to be 198 would be very useful. If you do that, what are the numbers that you find, Keely?
9 and 22.
9 and 22. And it's going to be negative 9 and negative 22. Okay, so you're going to know you have 2 binomials. This is the tricky part. Our binomials are going to be pretty weird looking. Because if you look at our answer, it's pretty weird looking. The first term, I know I need an a squared and a b squared. So my first terms, my binomials, are going to need to be a and b. So my first term, I'm going to put 2ab and 2ab. That's what makes this one weird. But I know that's the only way I can multiply to get that. It's the only way. My sides of my diamonds now plug in. Negative 9, negative 22. What's the problem? Why isn't this the right answer? I have too many 2's. So I have to divide one of these binomials by 2. Does the first one divide by 2? No. Does the second one? Yes, divide it by 2. And you'll get 2ab minus 9 times ab minus 11. And that would be your answer.